Hey guys, welcome back. Now continuing in the video series of this linear algebra for this data science, here let's see how we can perform this operation of reshape and modify the shape of my NumPy array object. Now this is very important. The reason because whenever we are performing the mathematical operation between multiple array object, we have to make sure that the sizes are compatible and the shapes are compatible so that I can perform my required mathematical operation. Else, obviously, we are going to face an error, be it simple machine learning or be it a very deep learning neural network. So always we have to make sure that the dimensions that we have in our input as well as the output are matching and we are allowed to perform that mathematical operation. So this video is very important and it's very important to know as how you can reshape the NumPy array object so that you can use it for your further processing. Okay, so if you are new to our channel, please subscribe us so that you are going to get the latest tips and tricks in the field of this data science, machine learning and deep learning. So let's get started guys. Now to perform this operation of this reshape, here I'm creating a NumPy array object. So this NumPy array object is having the shape of 4, 3. See, I'm having 4 rows and 3 columns. Now in order to perform this reshape activity, then at that time we have to make use of this reshape method. Now here in this scenario, I am performing the reshape of this original matrix that I have created, which has the shape of 4, 3 into a new shape of 6 by 2. Okay. Now to perform this, see, we'll specify the function that is reshape and inside the parenthesis, we specify the new shape. So I'm reshaping my original matrix into a new shape of 6, 2. So if I just execute this, see, this has reshaped the elements. Okay. So my original array elements has been reshaped to the new shape of 6, 2. That means 6 rows and 2 columns. Now this is very important guys. Whenever we are performing this reshape activity, we have to make sure that the number of elements that I'll be getting when I'm with this new reshape, it should be same as the number of elements that I'm having in my original array object. Now, as you're already aware, if I want to get the number of elements that are present in my NumPy array object, we have seen in our 2 videos back, isn't it? So we make use of this size attribute. So let me call this size attribute on this matrix object. So my matrix object is having 12 elements. And if you observe over here, I had specified my new shape as 6, 2. So 6, 2, that means 6 into 2 is 12. So the number of elements is matching with the new dimension. So hence I'm not getting any error. But if I give a shape where the number of elements are not equal to my matrix size, at that time I'm going to get an error. Now to show you this, I'll say it as matrix dot reshape. Okay, this time I'll give you a new shape as 7, 2 and I'll just execute this cell. See, I'm having a value error. The value error says cannot reshape the array of size 12 into the shape of 7, 2. So this is very important if you are making use of this reshape function. The new shape which you're giving over here for performing this reshape. So the number of elements in that new shape, it should match my original matrix or my original NumPy array object. Else we are going to get a value error. Now there is one more method guys that is called as resize. Now you have to be very careful if you are using this resize operation, because when you're performing with the help of resize operation, at that time the system is going to add or it is going to duplicate the values. Now to perform this activity of resize, here I'm going to call this resize function. Now to perform this resize, we'll call it as np.resize, and inside the parenthesis as a first argument we have to specify our original NumPy array, and as a second argument we have to specify the new shape. So I'll specify the new shape this time as 7, 2. Now if I just execute this, see, it has done the resize operation. And if you observe very closely, my original matrix has 12 elements. So at first, see, these are the first 12 elements has been added over here. Now to compensate for the other elements, what it has done is it has repeated the elements from my original NumPy array object. Now that's the behavior of this resize function. Hence, it's not recommended to use this resize function because we don't want to be ending up with modified inputs. So we don't want to do that, isn't it? We don't want to complicate the things. Hence, whenever we are working with machine learning, data science, and deep learning, we'll always and always prefer this reshape method over this resize method. Okay, and one of the common way that you'll be using this reshape method is you'll specify this reshape method and you'll normally convert it into a what I can say a single dimensional vector. So most probably you'll be saying it as okay, matrix.reshape 1, -1. Okay, and apart from that, if I want to perform any transpose operation in such scenarios, we'll make use of .t attribute. So here in this scenario, I'm creating a matrix and I'm just performing this transpose operation on this matrix object. So matrix.t. So this is going to perform this transpose operation on my matrix. And there is one more common operation. Yeah, guys. So this in this cell, I've just created a vector and this vector has been transposed. Okay. Now there is one more operation, guys, which I want to show you, that is called as flatten operation. And if I'm doing this flatten operation, it's going to convert and it's going to create a one-dimensional array object. Okay, so it's going to convert my two-dimensional array or multi-dimensional array into a single-dimensional array object. Now, this is what would happen if I'm sending any multi-dimensional layer or multi-dimensional object into a flattened layer. So if you remember, or if you're aware of this convolutional neural network, so after the series of convolution operation and the pooling operation, whatever the output that I'm going to get, which is in the format of multi-dimensional array, I'm going to send it to a flattening layer. So what happens in the flattening layer is it is going to perform this flatten operation in the backend. But in that scenario, we'll be working with deep learning frameworks. It could be TensorFlow or PyTorch, and it will be worked on a tensor object. Here in this scenario, we are just working on this NumPy array object and we are performing this flattening operation. Alright, now in this way, we play around with the shapes and sizes of my NumPy array object. And in general, if I'm talking in terms of linear algebra, in this way, how I can play around with the size and shapes of various mathematical representation of the data, that is vectors and matrices. So in the next video, let's see how we can find the rank of an array object and how we can find the determinant of an array object, that is matrices. Okay, so I'll see you in the next video. Take care. Bye.